will examine how to set absolute positioning for controls on screen, making it possible, for example, to overlap controls. We will also discuss the possibility to move, scale, rotate, or change the size of controls. Suppose that, when viewing a speaker's details, we want to see his or her full name over the photo. To do so, we need to define a control container with absolute positioning. Overall, this control is like a table, but it has a special name, canvas. When there's a canvas control in the layout, all the controls inserted within it will have absolute positioning in relation to the edges of the canvas. So, if we insert this control, we will have to set the distance from the upper edge, top, control height, height, and distance from the lower edge, bottom. On the other hand, the distance from the left, left, and the control width, width. Also, the distance from the right margin, right. By adequately assigning these measures, we can overlap controls. Therefore, we will also have to assign a value for the z-axis. This will determine each control layer to know which ones will overlap with each other. It assumes discrete values. 0 is the lowest layer, 1 is the following layer, and so on. So, if we open GeneXus, we're in the General section, in View mode, and we have the speaker's image and full name in two different rows of the table. We can edit the document outliner, which will be very useful in the canvas. Note that speaker full name is in one of the cells of one of the rows, and the image is in the first one. We will temporarily move the image down to make space, and in the first row, we will insert a control, canvas. If we now look at the row in the document outliner, we see that it's called Table 1. If we edit the properties, we can also see that it's called Table 1. Actually, we can convert a canvas control into a common table and vice versa at any time. Let's see what size the first row took. 150 dips. We'll add 10 dips so that it takes 160. Now we will insert the image within the canvas container. If we look closely at all the image properties, these ones are added under the group Absolute Position. These properties are those we've just seen in order to specify the absolute position of the control in relation to the container. So, if we move the image, we see that these values have changed. We will indicate that we want the speaker's image to be 20 dips from the left, and that its width takes 100% of the container width, but that it is also 20 dips from the right margin. Remember that the percentage is always applied to the result of subtracting the fixed values. In this case, the width value will be 100% of the total canvas size minus 40 dips, 20 from the left and 20 from the right. In addition, we will want it to be 10 dips from the upper margin, with a height of 150 dips. Also, the distance from the lower margin must be the remaining 100%. Since the cell was of 160 dips, and the height and top values add to 160, the distance from the lower margin will be 0. Note which order has 0 value in relation to the z-axis. That is to say, this control will be displayed below. Now, we will also want to move the speaker full name attribute inside the canvas control. Note that these group properties have been added again. Absolute position. Now we will configure these properties, indicating that we want this control to completely overlap with the speaker's image. All in relation to the lower margin. Therefore, its width will also be 100%. And the right margin will be of 20 dips. The top margin will be of 130 dips, because the control's height will be 30 dips. Together they add up to 160. Therefore, the remaining 100% will be 0. And the order relative to the z-axis will be 1, because we want this control to overlap with the photo. We will also change this attribute's class to attribute font color white with background, so that the background has some transparency and part of the speaker's image is displayed in the background. We delete the second row because we don't need it anymore. Be sure to note the following. If we now want to change some of the image properties, we can see that the image is overlapped in the layout. But we can still see it and work with its properties. But if we try to access the attribute properties, we see that they're no longer available. How can we edit it? Here is where we must use the document outliner, which allows us to select the control. In addition, note that all the controls located within the canvas control have these checkboxes to make it possible to hide the controls and show them in order to work with the various layers. Before pressing F5, if we run the application as it is now, we see that the controls are displayed in different cells of different rows. Now let's press F5. Now note how they overlap. Let's see another example. We're viewing information about a session and we want to see information about the room. The sessions given in this room are displayed in a grid. But also, it can be displayed by expanding the room's location in a map of the building. And this map can also be collapsed. This is an example of overlapping controls and also of shifting with motion. In the detail of work with rooms, we need one of the overlapping controls to move on the screen in an animated manner in order to achieve a dynamic user interface. Let's look into this. We can also access a room's detail from the menu by invoking the Event Explorer object, which is a manually created work with for smart devices, of which we only use its detail node, with its two sections, tracks and rooms, showing the lists of tracks and rooms respectively. If we pick a room from the list, such as Ballroom A in the example, the detail of work with rooms is invoked to see the details of the selected room. If this application is installed on an iPad, the list of sessions scheduled in this room will be displayed. At the top, there's a button showing an image to expand the map. We tap, and the map is displayed overlapping the grid below. If we tap again on the button, we see how the map disappears, and the original image is displayed again. How can this be implemented? We've already seen how to overlap elements. In this layout, in the same screen area, two controls are overlapped, that of the grid and that of the map with the button. How do we do this? We do this with the canvas control, as we saw in the previous example. Here we can see the layout for the iPad, where there is a canvas table containing one grid, which loads the sessions, and a table called Map Table, which implements the overlapping screen with the map and the button. In addition, we can see a checkbox that will be hidden and will be used to know if at that moment the table is expanded or collapsed. If we click on the grid and access its properties, we see the property values set for the group Absolute Position. Remember that the larger the Z number, the closer it'll be to the user. The 0 number indicates the screen background towards the back. Once again, we use the document outliner to access the controls placed underneath. So we can see how the grid has Z order equals 1 within the canvas. And here we see how the table called Map Table will be displayed on top given that its Z order is 2. We also see how its absolute position is set: left, width, right, top, height, and bottom. Note that its height is 625 dips, which corresponds to 600 dips of the first row plus 25 dips of the second one. The first row has the room map attribute, which contains the image of the room's map. Remember that this panel is called after invoking the detail of the work with device's room, so it receives by parameter the room identifier from where the room map is obtained. In the second row is the button that has a theme class assigned. This class configures the image to be displayed at runtime. And here we see the theme for iOS 7. Below the button class is the Mapdown subclass, whose background image is that of the same name, Mapdown. If we select it for the theme iOS 7, it's the one we showed at runtime. We also have the MapUp image that will be associated with the MapUp class below the button class. When we invoke the object for the first time, why is it that we only see the Expand Mapdown button at the top without the map, as if the entire table had moved 600 dips upwards, leaving the map image outside the layout space? This behavior is set by the class that we assigned to the table, TableMapCollapsed. This class was created by the developers for the iPad. Note that we've not only created this class, but we've also created another one below the transformation node of the theme itself. To the first one we assign, Among its properties, the second one. The second one specifies the behavior we see at runtime, of shifting of the entire table. The control associated with this class, through another one, which in our case is the table that has the table map collapse class, with the map collapse transformation, will move from translate by the x, y point indicated in the properties as anchor point x, anchor point y, in our case, the center of the table. In the y-axis, 600 dips upwards, using as coordinate origin, relative to the form. The origin 0, 0 is equal to the upper left corner of the form. In our case, the table will move 600 dips upwards. Since it's on the edge of the screen, this movement will leave the image out. Note that in the table class, the animated property is enabled. This movement will be displayed as such when the table is extended and collapsed. We'll talk about this next. When the table is moved up, collapsed, we will want to expand it when the user presses the map button. This means that we want to have it displayed as in design view, but in an animated way to give the sense of movement. How can we achieve the above behavior for the table? To move it in an animated way sometimes, and other times, when the user presses the button, to have it displayed as in design mode, overlapping with the grid. Also, note that the button's image must change in both cases. If we look at the expand button, it has the map down class of the theme configured in design mode, which in turn has the image configured. Remember that we've seen another class, map up, which has the other image configured. In the expand event, associated with the button, we will program its behavior in both cases, when the information is expanded and when it's collapsed. We simply change the classes of the table and the button, depending on each case. When the table has been moved, that is to say, collapsed, as in not expanded, the class TableMapExpanded is assigned to the table. It has the animated property and has an empty movement defined. It doesn't do anything. The button's class is changed so that it offers the possibility to collapse the information. Note that it uses a variable that works as a switch. Turn on, turn off. This started as false, indicating that it's collapsed when it started, and for this reason the table class at design time is TableMapCollapsed. In order to keep this variable value between executions, it's added to the layout, hidden. In this way, the second column is only added to keep on screen the value of the expanded variable, whose function will be to tell the event associated with the button every time that it's pressed, whether the necessary action is to expand or collapse. Because the button is hidden, and its space is not kept, note the value of the property, invisible mode, which can take the value collapse space or keep space. In addition, since we set 0 dips for the column size, it will not affect its display. If now the table is expanded, and we press the button, the table and button classes will be changed. Changing the table class will cause it to move 600 dips up in an animated way, which gives the impression that it's collapsed. Lastly, let's review everything that we've seen in GeneXus. We're in the Room transaction, Patterns section, Work with for Smart Devices, Detail node. Here we can see all sections content, where all the sections we have will be loaded. But we don't want this because we need both sections, the one showing the map and the one showing the grid with sessions, to overlap. However, if we run the application in Android, we open Rooms and select, for example, Ballroom A, we see that the detail is shown as 2 tabs. This is how we see them in GeneXus. Where is it programmed that in the iPad this is displayed as we've just seen? If we look at this layout, it corresponds to any platform, any mode and default orientations. But we have another layout defined, this time for the iPad, in any mode and with default orientations. Now we'll edit it. Here's the difference with the previous layout, which had all sections content. We see that, for the iPad, we only have the Sessions section loaded. And if we open the Sessions section, we find that, for this layout for the iPad, in View mode, we have the previous behavior programmed. If we edit the layout for any platform, we will see that it only corresponds to the grid. That is to say, for any platform other than the iPad. The detail will be displayed in this way. And only for iPad devices, it will be displayed in the other way. The topic of different layouts per object screen will be dealt with in the following video if you're taking the Smart Device course. To sum up, the canvas control is a control container which allows all its contents to take absolute positioning. Among other things, this makes it possible to overlap controls. You can read more about this control in our wiki. Transformations allow a layout control to be moved, scaled, resized, or even rotated. To this end, special classes are defined under the Transformations node of the theme. You can read more about this topic, as well as about the platforms in which this feature is available, on our wiki.